Alright, please put your pencils down. Do not copy off of me. Watch the video, learn how to do the problems, go back and do them yourself. It's the only way to learn. Alright, this lesson is going to be about finding the intersection of two circles. Step 1. Put the equations in general form. Alright, so look at the first equation we have here. Let me zoom in a little. Okay, so looking at the first equation, x minus 2 squared is like x minus 2 times x minus 2. Y minus 3 squared is like y minus 3 times y minus 3. If we multiply this out, if you do your double distributive property or FOIL or whatever you want to call it, we're going to get x squared. Hold on, let me move it down a little bit. We're going to get x squared and then minus 2x and minus 2x. I'm going to go ahead and just put minus 4x, and then negative 2 times negative 2, so that's plus 4. So that's what we get from that one. And then over here, doing the same thing, double distributive property. Alright, y times y, that's y squared. Y times negative 3 is negative 3y. Negative 3 times y is another negative 3y. So negative 3y and negative 3y make negative 6y. Just I'm going to do that part in my head. And negative 3 times negative 3 is positive 9. So we got that. Okay. Just cleaning this up a little bit, so we'll have we have x squared plus y squared minus 4x minus 6y. Alright, so the only thing I haven't dealt with yet is haven't done anything with the constants. So look at we got the 4 and the 9. So if I put those together, that's 13. Yeah, I might as well. Okay, fine. So put those together, I've got 13, and that equals 9. So of course I would subtract 9 from both sides at this point. Okay, and 13 minus 9, that's 4. So I'm going to go ahead and put that equation down here. So we've got in general form x squared plus y squared minus 4x minus 6y plus 4 equals 0. Okay, so that's the first circle in general form. I think I'll just switch colors on this one. I'll do purple. Okay, so that was the first one. And here is the second one. So let's see. So we've got again we've got x minus 2 twice, and then we've got y plus 4 twice. And that equals 16. So to write this in general form, again this is going to be x squared minus 4x plus 4, and this one's going to be y squared plus 8y plus 16, and that's equal to 16. Alright, I'm just doing the double distributive property just like I did up there. Okay, so cleaning this up a little bit, I'm going to have x squared plus y squared minus 4x plus 8y, and then there are the constants. So I've got this 4 and this 16. Together they make 20. So I've got plus 20 is equal to 16. So then I would subtract 16 from both sides. So minus 16 minus 16. Okay, so 20 minus 16, there's 4. Well, there's that 4 again. Alright, so I'm just going to go ahead and write this down below. Maybe I'll cheat and copy it. Alright, I'll just write it here for a second. So I'm going to wind up with x squared plus y squared minus 4x plus 8y plus 4 equals 0. Okay, so now we've got both equations written in general form, and step 1 is complete. Time for step 2. Step 2 says set the two equations equal to each other and simplify down to a linear equation y equals mx plus b. So it makes sense that we should be able to set them equal to each other, because see how they both equal 0? If they both equal 0, then in this form they should equal each other. So let's set them equal to each other. Alright, so here's circle A on the left, and here's the equation for circle B. So now let's clean this up. So we would subtract x squared from both sides, right? So those are going to just cancel out. We would also subtract y squared from both sides. So those are going to cancel out completely. Let's add 4x to both sides. So plus 4x plus 4x. Okay, so actually those are going to cancel out as well. Alright, that doesn't always happen. Now, as we subtract 8y from both sides, alright, that's going to give me negative 14y plus 4 is equal to 4. So this is kind of a weird one. So if I subtract 4 from both sides, not y, if I subtract 4 from both sides, I'm going to get 0. So that gives me negative 14y equals 0. Alright, this happens, so this is not really going to be y equals mx plus b, but it will be a line. We're going to divide by a negative 14. And we are going to get y equals 0. Now, y equals 0 is a horizontal line at 0. So just remember that. Anyway, we can still plug this in. It just really is simpler than it normally would be. So see where it says substitute mx plus b in for y? Well, in this case, we're just going to be substituting in 0 for y. Okay, let's just pick the first equation. So if I substitute 0 for y, then that gives me x squared plus 0 squared minus 4x minus 6 times 0 plus 4 equals 0. Okay? Just substituted 0 for both of those y's. Well, 0 is not going to really do anything, so I'm going to have x squared, so that's just gone, minus 4x, and you know, anything times 0 is just 0, so that's gone. And that's going to be plus 4 equals 0. Alright, so this looks like it might be factorable, so let's give that a shot. So x squared is x times x, and then 4 would factor as 2 times 2. And I'm looking at the middle of negative 4, and I'm thinking negative 2 and negative 2. Alright, these are the same, so I don't have to really do it twice, but if I set x minus 2 equal to 0, I would have to add 2 to both sides, and that would give me x equals 2. Now I'd have the same thing over here, but we've already got it, so we don't need it again. So we have our x value, alright, x is 2. Okay, now we already had our y value in the first place. Alright, our y value is 0 from before. So we don't even have to do that again. Okay, so there you go. Y is 0, so we have 2 comma 0. That's our only point, since that was our only value of x. So of course that means 2 comma 0 is our solution. So that means there should be one intersection point here. So that'll be interesting to see once we graph it. Okay, I guess really the part that I put here, this was step 4 when it says substitute the x values and find the y that goes with it. So this part that I did just now, that was step 4. So I'm just going to drag it on down here. All right, can I move this? Yeah. Okay, so that's step 4. Now, so we're at the end. So verify our solutions by graphing the 2 circles and the line. So let's take a look and see what's what. So remember, the 2 circles, the first circle has center 2 comma 3, and it has radius 3. Okay, you see where I'm getting these from, right? It's the opposite of these, square root of that. So let's do that. So 2 comma 3 would be right here. There's my center, and it said radius 3, so we're going to go out 3 in all directions. Okay, so that's one of my circles. Let's go ahead and draw the actual circle as best we can. Okay, so there's the first circle. Now let's draw the second circle. Alright, let me switch to pink for this one. The second circle has center 2 comma negative 4. Alright, opposite of that and the opposite of that. And it has radius of 4. Okay, so first 2 comma negative 4. So 2 comma negative 4 would be right here. And it says a radius of 4, so if I go 4 in all directions, I'm going to be there, and there, and there, and here. Hold on. Okay, let's draw that circle. Why did I make the other one pink? This one should be blue. Okay, so there's our first circle and our second circle. And you can see the point of intersection there, but let's follow through and also graph the line that we got. Okay, so remember, when we set them equal to each other, we got this line, y equals 0. So we should graph that as well. Y equals 0 is a horizontal line at 0. Okay, so that is this. Did it actually draw anything? I don't think so. Let me try that again. That was a fail. Okay, so that is the line y equals 0. So you can see that all three of these meet at a common point of intersection. Whoa. All three of these meet at a common point of intersection that is right here. And that is the only point of intersection. So that is the point 2, 0. Alright, so if we did this by graphing, we would come up with 2, 0. Now if we look back at what we got algebraically, we have that same 2, 0. Alright, so guys, listen to me carefully. If you ever get in trouble and you're having trouble with the algebraic solution, go ahead and just graph it. And you might not get full credit, but you're going to get most of the points if you graph it correctly and come up with the correct answer this way. So I think you'll agree that graphing is pretty easy. So don't worry. As long as you can graph it, you'll be okay.
All right, stop, collaborate, and listen. And while you're at it, put your pencil down.
That's right. I know you picked up your pencil while you were doing problem number 1. You know better. It's going to come back to bite you. Like, ah. All right, let's put your pencil down. Learn how to do it. Go back and do it yourself, people. You know better. What was I saying? Yeah, so as you can see, a real problem doesn't have the steps spelled out for you. So let's see how we can do just sort of doing this from memory, okay? Now, it's important that the equations are all flattened out, no parentheses, general form. You'll notice that these equations don't have parentheses. They are already almost in general form. We just need to put that 60 over there, and we need to put the 20 over there, okay? So I'm just going to stick it on here. So if I add 60 to both sides, like plus 60 plus 60, so there'll be a plus 60 on the end. And this one, if I subtract 20 minus 20 minus 20, there'll be a minus 20 on the end. So the next step was to set these things equal to each other. So that's what I'm going to do. So you would have x squared plus y squared plus 12x minus 14y plus 60, remember, and that should equal the other one, x squared plus y squared plus 2x minus 4y minus 20. Okay, set them equal to each other. Now let's simplify it and see if we get a line. We should get a line. So we're going to subtract x squared from both sides. Okay, so those are gone. We're going to subtract y squared from both sides. So those are gone. Okay, let's go ahead and subtract. Well, no, I'm not going to do that. If possible, I'm shooting for the form y equals mx plus b. So see how the y's are on the left and the x's are on the right, and the constant is on the right. So I want the y's on the left, so I'm going to add 4y to both sides, plus 4y plus 4y. Okay, that's going to move the y's over, so these are gone. But I want the x's on the right, so I'm going to subtract 12x from both sides, minus 12x minus 12x. Okay, so these are gone. And I want the constant on the right, so I'm going to subtract the one on the left, minus 60 minus 60. Alright, maybe I'm doing too much at once and I should have done one step at a time. Next time. So the y value, so negative 14y plus 4, that's negative 10. So I've got negative 10y, oh yeah, these are gone by the way, equals, alright, and then I get my x's, so I've got positive 2 and negative 12, well that's negative 10, x, negative 20 and negative 60, so that's negative 80. So I've got this. Let's divide everything by negative 10. Okay, so I've got y equals, now this is just 1, right? So I'll just put x. A negative divided by a negative is a positive, so this is positive 8. So y equals x plus 8. Kabam. So we've got our line. Now, once we get our line, we're supposed to take this and plug it into one of these two original equations. You know what? Later I'm going to have to try to graph this. That's going to be weird. I'll worry about that later. Anyway, I'm supposed to plug this into one of these. So, let's see. I like the bottom one, smaller numbers. So I'm going to plug into that one. So I think I'll just recopy it just to make it super obvious. So I've got x squared plus y squared plus 2x minus 4y. What should I do? So minus, I'll go with the minus 20 version. Minus 20 equals 0. Alright, so that was the second equation. So I'm going to take this and put it in for the y values. So there's a y value here, and there's another one here. Okay, so that's going to give me x squared plus, now here comes the y squared, but I'm putting in x plus 8. So that makes it x plus 8 squared. So then I've got my 2x from right there. And then I've got minus 4y again. And again, my y is x plus 8. Okay, and then my minus 20. Okay, so I've got all x's. So I should be able to solve this for x one way or another. So this is going to be x squared plus, now x plus 8 squared, that's, you know, x plus 8 times x plus 8, right? Plus 2x. This needs to be distributed. Treat it as a negative 4, all right? Not just a 4, it's a negative 4. So this will be negative 4x and negative 32, all right? Negative 4 times 8, negative 32, not positive. This right here is a common place where students will mess up. Equals 0. So we have to double distribute up in her. Okay, so I'm going to get x squared. Okay, and then plus x squared, and then 8x and another 8x, that's 16x. 8 times 8 is 64. Okay, let me go ahead and put these together though. So putting these two together, I'm going to have minus 2x. Alright, putting these two together, I'm going to have minus 52 equals 0. Alright, now I'll clean it up the rest of the way. X squared plus x squared is 2x squared. Okay, 16x minus 2x is 14x. And then I've got the 64 and negative 52. What's that, 12? Equals 0. Now, before I think about factoring or using the quadratic formula, I notice that there is a common factor here. So let's go ahead and just divide everything by 2. All right, we don't have to keep it off to the side like we used to because it's an equation. So this will be x squared plus 7x plus 6 equals 0. All right, this is looking factorable. So let's go ahead and just factor it. So x squared will be x times x. 6, I'm thinking 6 and 1 because I'm looking at the 7. And positive and positive would make 7x, inner and outer. So we set both of these equal to 0. So x plus 6 equals 0. X plus 1 equals 0. So that's going to give me x equals -6 and x equals -1. Okay, so we have the x values, but we still need the y values. So if I think of this sort of as a table of values, and x's and y's, so I have a -6 and I have a -1. Now I need the y values that go with them. Now I am using this line equation, the linear equation, y equals x plus 8, to get my y values. Okay, so I'm doing y equals x plus 8. So if I wanted to do this by hand, first I would plug in the -6. And so this would become y equals -6 plus 8. Alright, and that would give me y equals 2. Okay, and then, so I've got that, so that's 2. And then I would plug in the -1. Alright, so that would become y equals -1 plus 8. So that would give me y equals 7. Okay, so the solutions are, of course, -6, 2 and -1, 7. So that is the final answer. Okay, boom. So if we were to somehow graph this, these are the points of intersection that we should see. Now I'm sort of sad because these equations, they didn't give them to us in standard form. So if we really want to graph it, we kind of would have to rewrite them in standard form, which, you know, is we've learned how to do, so we need to practice it anyway. But I just wasn't looking forward to doing that. Let me create a space. Stand by. All right, look at the first equation. If we want to rewrite this in standard form with the parentheses so we can tell how to graph it, we're going to have to reorganize it a little bit. So I'm looking at that top equation. I see the x squared. I'm going to put the 12x next to it. Okay, and I'm going to leave a gap. Move over just a little bit. I cannot. Maybe I'll zoom in a little. Okay, so I did that. So I'm going to leave a space, and then I'm going to do the y squared. So plus y squared minus 14y. Leave another space, equals -60. Man, when you zoom in, you can really tell how messy your handwriting is. Anyway, I left a gap so we can complete the square with that magic number. Half the middle squared, remember? Half of this is 6. 6 squared is 36. Don't forget to add it to the other side. Got to do the same thing for the y's. Half of this is 7. 7 squared, 49. Add it to the other side. Alright, the point of this is so we could rewrite it as the same thing twice. So this is going to be x plus 6 times x plus 6. And this is going to factor down as y minus 7 times y minus 7 equals. Now, if you add all this up, let me see. So we've got -60 plus 36 plus 49. That's 25. That's nice. So all this is equal to 25. So that gives us x plus 6 squared plus y minus 7 squared is equal to 25. Alright, which of course means that we have a center of negative 6 comma 7. It's the opposite of this and the opposite of that. And then we have a radius of 5. So let's graph that. So negative 6 comma 7. Okay, so here's negative 6 and here is 7. So there's the center. Now a radius of 5, so 1, 2, 3, 4, 5. Okay, 5 will be just about there. Alright, somewhere around in that area. Okay, so there is our circle. So there's our first circle. We need to do the same thing with the second equation so we can see what the solutions are graphically. So let's see, the second equation, plus 2x minus 4y. Okay, so we need to get the x's together. So that's going to be x squared plus 2x, pulling those together, leave a space. That's plus y squared minus 4y, leave a space, is equal to 20. Let's see, half of 2 is 1. 1 squared, still 1. Half of 4 is 2. 2 squared is 4. Anything we're adding to the left, we need to add the same stuff to the right. So that's going to give me x plus 1 squared. And this is going to give me y minus 2 squared. Alright, and this is 25. Alright, which means we have a center of negative 1 comma 2 and a radius of 5. So negative 1 comma 2. Alright, negative 1 comma 2 is right here. A radius of 5. So that'll be here, 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 and here. Okay, so there are the two circles graphically. So as you can see, the points of intersection are here and here. I like this color better. Okay, so this point is the point negative 1 comma 7, and this point is the point negative 6 comma 2. Now, how does that compare with what we found algebraically? Oh, look at that. Negative 1 comma 7 and negative 6 comma 2. I think we have ourselves a winner. remember, if you're able to graph it successfully, even if your algebraic part is wrong, I'm still going to give you most of the points if you can graph it right and come up with the right answers. So just be able to do, basically I'm saying make sure you can do at least one or the other. Either be able to graph it, which most kids find easier, or be able to solve it algebraically. Alright, either way, that is the end of this video. I hope it was helpful to you, and I hope you didn't copy off me. And I'll see you on the next video, people.